Now, it may seem like you hear about surprising new and different applications of artificial intelligence all the time. You know, what are they going to think of next? But it's important to understand that the core technology that's driving those advances is actually pretty much the same for all of these different areas. Virtually all of the applications of AI that you see today, from self-driving cars to product recommendation engines to programs that will deal with cyber attacks, those are all applications of the same machine learning techniques to very large collections of data. Now, sometimes that data comes from traditional databases, and other times it comes from data that's streamed from real-time sensors, like microphones or cameras, or what's now coming to be known as the Internet of Things. There's going to be data streaming from everything quite shortly. So, a useful way to think about modern AI is that it's a terrific new way to extract value from very large collections of digital information, which we're swimming in oceans of it. So if you want to identify applications and how you can benefit from them, you simply have to look for these big collections of data. That's where the action is going to be. And the cool thing is that the collections, they don't have to be clean, they don't have to be structured as you would with a traditional database. They can be surprisingly dirty or noisy in the statistical sense. In the machine learning programs, they vacuum up all the data and they clean it up and they spit out little tidy generalizations or observations, like that's a cat, you know, and here's your face in your the viewfinder on your camera when you're taking a picture. That's all applications of this kind of technique. So now I want to talk a little bit about applications and some of the things that you're going to see with artificial intelligence. Now, there are a very wide variety of applications, but the most common ones tend to fall into certain kinds of classes. To me, the most obvious, because it's the most tangible, is a new generation of robots that can work safely in and around humans and people in human spaces like this. Now, with very few exceptions, today's robots are actually confined to factories where they perform simple, repetitive operations. Now, you know, they just pick up something or move it from here to there. The reason for this is that most of the machines today can't sense anything about their environment. And therefore, they can't adapt to changes in those kinds of environments. So they can only work in very carefully controlled settings, like a factory floor. But using the new artificial intelligence, we can now give those robots the equivalent of eyes and ears. So they can sense and interact with their surroundings more like the way that people and animals do. So the new flexible robots are going to be able to work alongside people in real environments because they can adapt to what's happening around them, because they can sense that. So you may have seen something like this. Self-driving cars are the first examples of these, one example of these new kinds of flexible systems. But it's only one example. In this video, you can see the human's view is at the left, and at the right is sort of what the, boy, it's really jerking around for some reason. You can see what the car is seeing. Now you notice here, the human gets out of the car, and the car waits until these people are crossing the street, and when it thinks the coast is clear, then it goes forward, and then it parks itself. Now I will say, having been walking around Rome for the first time in my life, you don't have to worry about this technology. It's not coming here. This will not work here. Now here's another one of my favorite examples. These are little robots in what are called plant nurseries in the United States. And these are little robots that are picking up and spacing out the plants as they grow, and they need more space so they can have light and air. The robots locate the plants, they pick them up, and they move them to the new locations where they can grow better. So this is in actual operation in the US. Now this one, the case of flexible robots, The data, as I said, comes from sensors like cameras and radar. And that allows the machine learning to do what's called image recognition, which is how they figure out where these things are. And they extract the patterns out of that, and they stream from these streams of data. And so it can identify the nearby objects, and they can program the robots to do the appropriate things in their environment. So in addition to the self-driving car, this particular video is an example of a robot that was nicknamed Big Dog. And it uses image recognition to navigate and walk through a forest. And also, you can see how this same technology can be used to build a machine that can climb stairs. Okay, now one of the most remarkable advances is in what's called swarm robotics. And that's where collections of robots communicate and coordinate their activities at a level of precision that often humans can't possibly achieve. These two robots, let me start this up. These two robots are engaging in a game of catch, throwing the ball back and forth. Now these are deciding, coordinating among themselves, how to maintain their formation as they move through an open window. And this one I love. That machine is actually, the drone is actually balancing that stick, and what you're going to see is how these two robots can coordinate to juggle this stick. I find that quite remarkable. Now soon we're going to see flexible robots like this everywhere. They're going to be painting walls and buildings. They'll be cooking meals, serving food, clearing dirty dishes, making beds, washing laundry, laying pipes, cleaning sidewalks, fetching tools, and carrying around our bags. And that's just a few of the examples of how we're going to apply these kinds of new robots. Okay, another major advance made possible by machine learning and artificial intelligence is the ability to read and interpret written language. And that can be language from prepared documents like newspaper articles to text messages that people might send to each other. So AI programs can be used, for instance, to provide automatic summaries of documents, or to answer questions, or to do translation between languages. Another area of application, which I think will have a major impact, and already is having an impact, is to make it easier for us to use computers. Now in the past, people had to learn how to use the computer. You had training courses to try to use computers. But now the computers are able to interact with people in much more natural ways, about the ways in which we tend to interact with each other. So in particular, advances in speech recognition now make it possible for you to use your voice to issue certain kinds of commands, or to dictate certain kind of messages, or to ask questions. Last night when I went to bed, I told my phone, by speaking to it, wake me up at 8 o'clock in the morning. And much to my surprise, it worked. Okay, now you might think that machines don't have human emotions. And of course, that's absolutely correct. But it doesn't mean that they can't sense and respond appropriately to human emotions. So you might be surprised to learn that a new field in artificial intelligence, which is called affective computing, is concerned, just to go back, wrong hand, is concerned with recognizing human emotions. These new programs, like impatience or sadness or anger. So the applications then can tailor their responses appropriately to the human emotions. For instance, if you're hesitating or if you look frustrated, a computer program can offer to maybe some more help or suggest what you might do next. And that's the application of this kind of technology. Now, another use of AI technology that will greatly assist people in doing their jobs is what's called augmented reality. And that's a fancy name for basically eyeglasses that can display semi-transparent images over whatever you're looking at. And these systems can scan your environment, and they track the position of your head, so they can lay labels over what you're seeing. Now, this is an example of how it improved performance on a complex wiring task by 34% in this particular example. So instead of having to stop, like the guy on the left here, and check the paper to figure out what to do, the guy on the right, it was just displayed directly into his visual field. It's the same guy, by the way, I noticed. Not at the same time. And allowed him to stay focused on the task while he was getting the directions that he needed. And as you can see, it's much more efficient to be able to do this. Now, another major application, which is going to be a lot of fun, of virtual reality or augmented reality, is to entertainment and to games. Now, this is an example of a recent demonstration that was done by Microsoft of a headset that overlays special graphics remarkably on top of real objects in the room. So it can see what objects are in the room and actually integrate this game with those objects. So you can see how it integrates with the walls. And in a second, you'll see that these little virtual pictures of robots can actually do things like crawl over the furniture, which I find quite remarkable. So here it comes over the couch. This is going to be really scary to have this at home.